Welcome to our webcast on MapSight today. My name is Kevin Foss, and I'm the Director of Utility Solutions at Ike's GPS. Today's agenda, we're going to cover utility asset collection from the standpoint of the what, where, why, and how of your data collection efforts. We'll introduce you to the MapSight solution and give you an overview. We'll give you a feel for using the MapSight product in the field. We'll look at some field data collection examples. Then I'll go live into a MapSight desktop demonstration, share some case studies of customers that have already embraced the technology and seen tremendous gains on their efforts. And then also we'll get into some potential next steps, download resources, as well as some Q&A. So just a quick bit about Ike GPS. Ike stands for I Know Everything. We've been developing and integrated mobile solutions for measurement and remote asset management since 2005. Our technology has been adopted around the world in major utilities, engineering, telecom, public safety, government and defense agencies. We develop, manufacture, sell, and support the MapSight product. Our headquarters is in New Zealand, and we have several U.S. offices for sales and support throughout the U.S., and also we distribute through a global reseller network. Late last year, we partnered with GE. GE certified that our technology and manufacturing processes met or exceeded their high quality and reliability standards. And now the Ike GPS product has been rebranded to MapSight and is sold independently under the GE brand. So as I talked to you earlier in the agenda, throughout the course of this presentation, I'd like for you to be aware of certain things about your current assets you collect and how you collect information on them. So the first is I ask you to think about, what do you measure? What are you trying to collect? Second, I like for you to think about the why. Why is the data being collected? Is it a situation of regulatory compliance or inventory, or potentially to make estimates and make ready? These are just some of the things that we hear from our clients of how they're utilizing the MapSight technology. In addition to the why, think about the conditions. Where are you collecting this? Are you collecting mid-spans in a road and have to get in a road to potentially stop traffic? Several of these things are the key attributes that MapSight as a single device allows the user to have capabilities. To stay out of the road for safety reasons. They're able to stand in one position and collect many targets from one position. Unrestricted access. You'll find that on the device you have tools to be able to zoom up from far away assets. You're able to pretty much collect anything behind a fence or that's out in a field. We can measure anything you can see and take a picture of, we can measure. And most importantly, you always can verify your target. Oftentimes we hear from people who are using more traditionally piecemeal methods of collecting data. Oftentimes they're not assured of exactly what they're collecting. So with us, you're always seeing a photograph, so you're verifying your target. And probably the most unique feature of our solution suite is the ability to take pictures which are calibrated, which allows the user to be able to measure and mark up and record this information on the desktop. That information is not only available as the photo, but also it's available as rich attribute information, which we'll get into in just a little bit later. So now we come to the how. How are you collecting it? Are you collecting with manual means? If you are, you may be able to collect things with the digital camera, but oftentimes you can't correlate that with the GPS position, or more importantly, with valuable attribute information. So we've depicted a typical scenario here of a manual methodology for collecting midspan, but with our all-in-one device, you can either limit it down to one person, or at least you were out of harm's way, so you can take a picture of the wire and calculate the midspan without having to get actually in the line of traffic. This piecemeal approach in the current state doesn't afford us the ability to take all the data and draw it together digitally. So it's ripe for transposition errors or requires a lot of manual entry. So I'd like today to introduce you to the MapSight solution. It uniquely delivers laser accurate remote photograph capture and allows measurements on geolocated remote assets. This is just a few of the companies that have embraced our technology. Everything from utilities to communications companies to service providers to engineering companies. So what is the solution? It's a combination of an all-in-one device, along with specialty tools for the utility market and for remote asset location and measurement, combined with a desktop application that allows you to then ingest the data collected into these integrated environments. So natively, you'll see how we can put our photos directly into these environments. And just to show you that it's ready to go, this is the way the product will be shipped to you. You'll get 2 batteries, you'll get the device, you'll get a tripod, you'll get a couple power supplies, and you're ready to go to the field for a full day of work. Let's start off by looking at the first piece in the solution, the device itself. What we've done is we've actually combined a sub-meter accurate GPS along with a digital camera and a laser rangefinder. Coupled with that, a digital inclinometer and compass. That all is wrapped in a mobile ruggedized computer that's military tough and ready to hit the field. The data is collected on an SD card, and all this information is collected by the different devices, so the instruments are combined with these tools. So these MapSight tools are the tools that drive the different devices to specifically capture some of their most critical utility needs. Let's go over a few. Target position allows us to take a quick picture of any asset, in this case a photo of a pole, for quick inventory. So it gives us the geospatial location of it as well as that picture. 3-shot height is used in instances where a vertical asset may have its base obstructed, like a wall or vegetation. So we still can calculate the height of that asset even though we can't necessarily see the base. Span height is basically to take away the old manual method of having a stick and being able to calculate by measuring the span of the height of the wire by highlighting the wire and then moving underneath it to calculate its perpendicular point. Missing line is a very, very versatile tool that allows us to capture points between any 2 points. That could be horizontally, it could be vertically. As you'll see later, we use it in a variety of data collection applications. And then finally, photo only. Although all these tools contain photo and geospatial location, photo only gives us a quick ability to capture ancillary geotagged photos. Could be instructions or could be just a quick photo. Complementary to the device and the MapSight tools are our MapSight desktop software. It serves 2 purposes. The first purpose is allows you to take the tools that we'll go over in just a minute and define them in such a way, along with custom forms, to make sure that you're able to consistently collect the data. That's all in a drag and drop interface, which we'll get into a live demonstration in just a moment. Second is after the data has been collected, the desktop is where you report on the data, as well as you can actually take the data and mark it up, or in this case a pole, and mark it up and then have those attributes available to you in the embossed image. All the data we capture can report or integrate into some of the following back-end standard formats as well as Office systems. Highlighted here, CSV files, KML for Google Earth, XML obviously is a PDF for reporting, and then a variety of back-end systems like MapFrame and FieldSmart, as well as Google Earth and Shape and others. So let's look from the user's perspective of how the tool is used in the field by identifying each one of these tools and their function. See how those storage containers are way off the road? In normal circumstances, we'd have to get permission from the owner to go up there and potentially take pictures and record any information about them. But with the MapSight device, we're able to zoom in on our target. Notice there's some crosshairs that allows you to understand exactly what you're shooting, and also you get feedback directly of how far you are away from that asset. You take that picture, you associate a label, and then we go to the next tool, 3-shot height. So once again, the user is presented with a selection of a tool. In this case, there's vegetation around the base of the pole, so you can't possibly see its base. So what you're going to do is you're going to estimate where the actual ground is of where the pole should be, and then with other subsequent measurements, you'll be able to calculate the actual vertical distance. Notice that the tool is giving you feedback of what tool you're in, as well as where you are in that sequence. It's saying aim at the ground. Now it's asking me to aim at the vertical. Notice the device here has been changed. And then finally, aim at the top, which is the resultant 32 feet. And then that's the way the user will be presented with the actual information in the field as that leader drawn at 32 feet. Span height. Remember, we had depicted the old manual way of doing it. So this is the way we would do it. We would take the tool, this would be on a tripod, and notice that we zoom in to that specific wire using our zooming capabilities. Also notice that we're 67 feet away from this particular wire. And notice also where we are with the tool. It's telling us for span height and where we are. So the next sequence will say aim at the ground. What we're doing is we're trying to identify the perpendicular point underneath that wire, which will give us the actual midspan over the road. Notice that the tool is indicating to us that we're aimed 107.4 feet. We're way out here. So the tool is intuitive enough to go ahead and lead the user by moving it down and to the right to get closer to the street center line, which is where indeed that midspan should be calculated. And the final result is drawn here. Next, we've got missing line. As I mentioned earlier, it allows you to calculate points either vertically or horizontally, point A to point B. In this case, we're doing an actual span between poles. And once again, the tool tells me to aim at the first. It's telling me exactly where I'm aiming with that bullseye. It now has a streaming laser to indicate exactly that distance. And then that leader is drawn to match that distance. And then finally, as far as this set of tools, we have photo only. A lot of people use this tool basically to assure birthmarks or pole IDs or any special instructions that may need to be associated with the data collection. In this case, we're adding a label and also a comment. We'll get into more sophisticated forms creation associated with the data collection in just a moment. This is the calibrated technology we call true size pole. What it allows you to do is from a single shot, take a picture of a pole. Ideal scenarios, if you can see the base and the top, that results in us being able to bring it into our MapSight desktop. And then the result is us being able to mark up, annotate, and measure the attachments on the pole. So let's look at some quick field data collection samples from our customers. Even though this tool is geared for the utilities, there also are associated assets that people can easily collect. Here's just a few, particularly something like fiber to building, which is becoming more and more of an attribute in order to be able to get buildings quickly rented, down to manhole covers, down to just traffic lights. This is an example of using a three-shot tool. In this case, this is a new construction facility. They're getting ready to add another tower, and they wanted to know the height of the current tower. In this case, they were able to shoot the ground, shoot a vertical, and shoot the top to calculate that final distance of that vertical structure. This is a span between two poles. While we're capturing this data, we're able also to capture various pieces of information like azimuths to calculate angles for service links and angles coming off of poles, which our customers find important. Midspan, from the safety of the road, the person's able to shoot the wire, calculate the perpendicular distance without having to necessarily stop traffic or be actually in the road. This is using our missing line tool. However, we're using it to calculate clearances. In this case, it's the vegetation and closest to an actual wire. So you'll see the missing line tool used in a lot of different areas. This is kind of hard to see, but I think it's important to point out. In this case, this is in rural Arkansas, or in Arkansas, and they were basically had to measure the height of this pole. They were creative enough to put in an offset stick of 13.2. You barely can see it, but they, from that reference point, they were still able to calculate the height of that pole as well as identify all the attachments on that pole. And with the expansion of all the different communication efforts that are going on throughout the United States, our tool has been used most recently for smart grid and wireless site survey. So the important part there is a lot of times they'll need to find on a street pole where from the engineering drawings which ones have power, where they can tie into, because they may have to, well, they do have to drive power to run those devices. The effort with these Wi-Fi's is to create these contiguous clouds in areas around universities, malls, stadiums, things where people might want to have Wi-Fi's, and even cities. In New York. What I'd like to do is move from the device and get into a live demonstration of our MapSight desktop. Quick reminder, it's for forms creation as well as the ability to measure poles and photos after they're shot. You should recognize these tools that we pointed out earlier. So it's in this particular forms generator that we actually will create a customized form. I already have one up, but let's go ahead and create a new form. Typically what we find is that when people will start using the MapSight device, their workflow may indeed change. So in other words, they're going from a piecemeal approach to an approach where they have a single device. What we find is that they may start away from an asset and move towards it versus maybe starting with it and move away from it. So keeping that in mind, I'm going to arrange some tools to do a very, very simple pole data collection. We'll start off with just a target position. And in this case, we're going to notify the user that it's just a pole picture. Second to that, we'll take a true size. And the true size, just to remember, this is that special tool that allows us to calculate off the calibrated image the measurements after it's collected. So we'll just say true pole pick. Next, since we're away from the asset in most instances, this case, let's go ahead and do a missing line. Now, missing line was that versatile tool I told you about earlier that can allow us to do things like calculate a forward span, back span. Also, while we're there, maybe we'll go ahead and calculate a mid-span. Now, the other things I'd like to point out is in addition to the tools, we also have these field data collection capabilities as well. So we can complement the data collection with attribute collection. So maybe the first thing that we're collecting is pole ID. And as I mentioned earlier, maybe what we would want to do is we would want to go ahead and accompany a photo over it just to ensure that the ID was indeed keyed in correctly. Also, our choices on these fields could be something like a numeric field. Maybe that would be the consideration of the class of a pole. We have lists. It can be something as simple as pole material. And in this case, what you can do is you actually can put discrete values for the user to choose from to ensure data integrity. And then maybe we have here at the bottom a yes/no kind of Boolean that damaged. And then what we'll do here is we'll say, hey, the default value is hopefully the poles aren't going to be all damaged. So let's make the default value maybe no instead of yes. And we'll say it's the last time. So hopefully we're not in an area of damaged poles. I'm going to save this real quickly. And then the next scenario for me would be to physically deploy this to the device so that way we're actually instructing the users on how to collect data. Now, since I said you're going through a transition where you may be changing your workflow, this drag and drop interface affords us very quick, nimble capabilities to move things around. So maybe we identified pole pick needs to come later in the sequence. So hopefully you can see how easy it is to configure and build forms, custom application forms. Before I leave this, I want to point out something, that behind the scenes, in this case, this is just missing line. Look at all the information we're collecting upon taking the picture and the associated instrumentation. So all of this that's checked is available in the CSV file. The other information can't be extracted, but it's not necessarily as easy to get to as it automatically being ready for the CSV. So I told you earlier the desktop performed two functions. The second function is the actual looking at the data, and then finally being able to go in and actually mark up and measure attachments on a specific pole. So the data is presented based upon each tool. So let me just scan through some of these. So this is missing line, and it shows you the versatility. In this case, it was a span. This is another span. But then look at this. This was used basically to capture the vegetation encroachment directly for a wire. Span height. And then once again, creatively using the span height in this case to catch the incremental distance between two wire services. Here's an example of 3-shot height. And just a quick reminder, that was an instance where the base of the pole was obstructed. So we merely did that 3-shot step to calculate the height of that pole. And then finally, these are the true size photos. And what a true size photo allows me to do is has a series of tools that allow me to measure and mark up the pole after the data has been collected in the field. You'll notice here that we have an 8-foot offset stick. We recognize that it's not always ideal situations where you don't have it obstructed either vegetation or a wall. So sometimes we'll use the pole, and our customers sometimes use poles as reference points as offsets just to make it easier. So to quickly familiarize you with these tools, we've got to set the ground. We got the ability to measure the attachment height as well as its width at that attachment, add in various comments, be able to change the colors of the actual red lines that go up, and then finally set the tip of the pole. So I'm going to begin by going ahead and, in this case, assigning an offset of 8 feet by zooming in to the top of this stick. So note that it's looking for ground zero, but in this case I replace it with the 8 feet. And it's calculated the 8 feet to calculate the ground down at the bottom of that stick. So once I have that baseline established, let me go in and mark up some utilities. So maybe this is cable TV. I can identify equipment. Also, in this instance, what I'm going to do is I'm going to potentially mention where fiber might be installed. So I'm just going to pick a point, put in fiber install. We don't know that that's where it's going to go, but that's just kind of how it's been proposed. And then moving up the pole, I can add in a few others. And you can see how easy it is to scroll through some of these attribute names to make it very, very easy and consistent when marking these poles up. One thing they did want me to find out at the fiber install point, we wanted to know the actual thickness. So I'm going to move it around the other side, hit it over here. Notice I'm using my arrow keys to snug up these calipers directly where the intended width of the pole for the install is going to be. Oftentimes, in addition to the attachments, people want to assign labels, and any number of these labels will go now on the embossed image. So I'm going to add a couple more. Maybe make ready is required. I'm sure you can find a lot of different applications for this annotation capability on top of the embossed image. Let me go ahead and set the tip of it. And then that is a quick markup of a pole. Now what I'm going to do is I'm going to go ahead and save the embossed image. And what I can do, as I said earlier, is I now can see these poles directly in Google Earth. In addition to the embossed image being ingested into Google Earth, the values that we assigned are immediately populated as CSV. So now we can just go and review some of those that we put in there. The base offset, the lamp post, the fiber install. You can see the different values that we had highlighted on our attachments that now are available in a report format, including longitude and latitude and other information specific on the more the GPS side. So now just to revisit the solution, the device, we've shown you the tools, we've shown you the desktop, show you some capabilities with integration on the Earth side, and then also, of course, the device itself, or the actual outfitting of the device. So now let's get into some real live case studies of why people actually bought this technology, and more important, what results they've seen from it. So the first one we're going to look at is Hinkles and McCoy. The big news here is that Hinkles and McCoy increased their pole collection capability by over 125% using GE MapSight. Now they attributed that to the ability to easily create custom workflows and forms that represented their true day-to-day field data collection efforts. So to put that in perspective, they went from collecting 20 poles a day to over 45 poles a day. And that enabled them to meet a project 16 weeks faster than they originally had intended to do it with other equipment. Also, they cited that the digital data collection and measurement meant the verification of the results collected had little, if any, transcription errors. And one thing they found out was very useful for the client is the ability to have a photo verifiable evidence. So you're always able to show the progress of your projects and the as-built conditions of your assets. Another organization, JMC, was able to take a two-man team and put it down in a one-man team, therefore doubling the amount of poll data they could collect. They also were keen on being able to use the data after it had been collected to put it into environments like Google Earth or into spreadsheet environments, and cited that collecting the data with the MapSight device enabled them to quickly get it into the back office. And their customers are very happy because what was happening is they were getting much more detailed information to their customers to be able to illustrate what work they had done. And most importantly, they were going from using a Hastings stick, and they rave over and over again that they're within an inch on accuracy. So hopefully you've seen that the MapSight solution is a very, very versatile tool. You've seen a variety of applications that it can apply to, several of which are here. Anything from taking a single picture of a pole and be able to measure its attachment to more complicated calculations like a midspan, but from the safety of the road, or vegetation clearance, how close a limb is to a wire. So I'd like to quickly go over some of the unique benefits in our MapSight solution. First of which is safety. You can capture data without having to be in harm's way. So if you have to go to a road or a canyon or a river, it's very easy to collect data with our MapSight tool. Also, as you saw, there's onboard tools to allow you to zoom up and capture information that may be hard to reach. Our motto is, if you can see it, we can capture it and measure it. As you've heard, we have a unique set of instruments that are combined in our device. That allows us to tout accuracy on attachment heights using our true size capabilities within an inch. The tool's accuracy leads to us being able to complement that with customized forms that make sure you capture all the data, and most importantly, you're consistently capturing the data. That consistency and repetition leads to efficiency, so you're getting a lot more data collected because they're really used to the process. That leads to speed, and that over-encompassing leads to ROI, or greater, more accurate data. The tool that I showed you today, the MapSight desktop application, you can go and download that for free. Also, there is a lot of information in the form of white papers or brochures available at our website. You also can just contact me directly if you'd like to do a demo or need a quote or have some questions. Getting back to the MapSight desktop software, it is equipped with sample photos, so you can go in there and mark the photos up. You can create your own files and then ingest those into a variety of applications. So at this point, what I'd like to do is turn it over and see if we can answer some of the questions that have been polling up here. Brian, do you have some questions you'd like to share with the audience?
First question, user asks, do I have to use a tripod with all the tools? For most of the tools, yes, you do. Missing line, 3-shot height, span height, those you need to use a tripod to get accurate measurements. We do recommend that you use it for the true size also, because we found that you get a little better accuracy utilizing the tripod on that tool as well. And most of our clients, we found in their custom form development workflow, they not only have the true size, but as you saw Kevin demonstrating, they're also doing the span height or maybe the missing line, stuff like that. So it's just easier for them to do everything all in one as far as that goes. Most of them have just decided it's quicker just to leave it on the tripod the whole time that they're working. Another question, user asks, can you manually move the gray boxes on the MapSight embossed image so that the box does not obscure some other feature in the photo? Actually, no, not the actual measurement where you've clicked and measured an item and labeled it. The ones that were on the left, the manual label items, you can move. The only thing we can recommend is if that is blocking something, you can make the font a little bit smaller so that the embossed writing will not take up as much space. The other one, let's see here, they're asking, will we be upgrading to the Archer 2 for it? No, we will not be. At this time, we do not have any plans to utilize the Archer 2 for the unit. Does the device have comms that enable the workplace to upload and download from site? You can get a Wi-Fi SD card. We do have a couple of clients that do that, but mostly they're downloading the data at the end of the day to their computer, and then from their computer they're sending the data either to a server or to whoever needs to utilize it. How do all the measurements from the different tools taken for a poll relate back to that particular poll in a searchable result form? As you saw, everything will be in a CSV file format. Depending on what you want to do once you've done the measurements with that CSV, if you're pulling into a GIS system or something like that, then you'll be able to reference that poll and any info on it. Are the lat and long coordinates in the CSV for the poll target for the position of the map site at the time the data was collected? The lat and long coordinates in the CSV for the poll target, they are for the poll target. Now, you do have the ability in the custom form workflow development, if you want to export the coordinates of the unit itself, okay, you have that ability. But if the Google Earth would have worked, you would have seen that it not only shows on the Google Earth where the target location is, but it also shows where you were standing. It'll show a little symbol of the MapSight unit and a blue line to where you were shooting. So the CSV normally will just have the coordinates of the target itself. How accurate is the device? Depends on which accuracy you're requiring about. The positional accuracy of the unit itself, if you're meeting all our criteria as far as good satellite coverage and all that, you're looking at sub-meter at the unit, probably about a meter, maybe a little over a meter at the pole or other target item that you're looking at. And then for the measurement capability in the true size, our clients have been coming back to us and telling us that they're getting plus or minus an inch on their measurements. Does any other questions or anything out there? Thermal camera? No, not at this time. That's more of an engineer question for the guys in New Zealand, but I know at this time, no, we do not have any plans to do a thermal camera. Are there any plans to integrate with Osmos OCalc? We are looking at some different software, pole loading analysis software packages. I would have to double check and see if we're looking at OCalc specifically. As you know, we integrate directly right now with PLS Poll. And do you have any insight, Kevin, on any others that we're working on?
No, those seem to be the two that we hear the most right now.
So, and I know SpiderCalc also, that there's some talk about that one, but I don't have any specifics on that. I don't have the marked up, but this is what you would actually see. This is the pole that was captured. There's where the unit was, shot across, captured the pole. I really don't have much marked up on it, but once you mark up the items, then they would also show up in the photo and any other data that you captured. In this case, it was just a basic label and comments on it. If it would have been a custom form type thing with a lot more data, then you would have been able to view all the data captured. Now, if you're taking multiple pictures, you're only going to have the ability for one picture to show up in Google Earth right now. So just be aware of that. When you're doing your custom form building, you have the ability to select what you want to show up and where. Okay. So if I did a missing line also, I could have maybe the missing line show up instead of the true pole size, true pole pick. So different capabilities there, different photos you can have show up. But we are talking about, hopefully down the road, to be able to expand that some to where you'll have more flexibility in what you're doing there. Google Earth, how would I do a search using a pole ID? I don't know that one, if that's possible. So that one I cannot answer. I'll find out if that's possible, but at this time I don't know of any way to do that. That is all that I see, Kevin, so I will turn it back over to you.
All right. Like I say, these are resources and our information. Once again, we really appreciate you spending time with us today, and feel free to keep the line open communication and send us any additional questions or comments that you might have. At this time, I'm just going to go ahead and conclude this webcast. Thank you very much.